Since we are evaluating limits at infinity, there are going to be a couple new indeterminate forms involving infinity that are going to show up. So here are some examples of indeterminate forms involving infinity. First one is the indeterminate quotient. An indeterminate quotient is what happens when you take the limit as your variable goes to infinity, and you wind up with a fraction of the form infinity divided by infinity. This is an indeterminate quotient, and we need to take the appropriate steps to evaluate it. The indeterminate product is when you have something that is approaching infinity multiplied by something that is approaching zero. 0 times anything should be 0, and anything times infinity should be infinite, so the product of those two quantities would be a contradiction as well. And finally, the indeterminate difference. An indeterminate difference would be of the form infinity minus infinity. In a case like that, you have to pose the question, whose infinity is bigger? Sometimes you get positive infinity, sometimes you get negative infinity, sometimes you get 0, sometimes you get 4. Because, infinity plus 4 could be infinity, so infinity minus infinity could be 4. Why not? In addition, we should probably talk about some forms that are not indeterminate involving infinity. So infinity multiplied by infinity is not indeterminate. You are allowed to conclude that that thing is equal to infinity. A number divided by infinity is not indeterminate. That thing is equal to 0. And infinity divided by something that is finite would be infinity as well. Now, do keep in mind that these are all of the form of limits, so I'm not saying that you actually plug in infinity to get any of these. These all exist only as limits. Let's see, any other good ones? If you have infinity plus infinity, that is not indeterminate. That will be infinity as well. So, just a couple of examples of things that are indeterminate or not indeterminate involving infinity.